So this is question 2. So for this one, we're looking at just derivatives and a bit of calculus. We've got the curve C here. Y equals x squared minus 2x minus 24 times root x. Part I, find dy by dx. Part A, find the second derivative. Part B wants us to verify a stationary point, and C wants us to determine the nature of this stationary point. So let's do this. So part I first. We've got to find the first derivative. So I'm going to call it y prime, just to make my life a little bit easier. So y prime. So we're just going to differentiate each term going along. So x squared, that will just become 2x. Minus 2x, well, that'll just become minus 2. And then the 24 times root x, well, that's minus 24 times x to the half. Well, if you times 24 by the power and then reduce the power, just like we did with differentiation, that's going to give me minus 12x to the minus half. If you take 1 from a half, you get minus a half. Now remember, you've got your calculator for this, so don't worry about doing these powers off the top of your head. You know, use your calculators, guys. That's what they're there for. So that's your first derivative, and that's what you're aiming for. 2x minus 2 minus 12x to the minus a half. You can rewrite this if you want, but both methods are acceptable. The second derivative, so I'll call it y prime prime. Again, just to make my life a little bit easier. So this is just notation from the second derivative. We've got to differentiate this function now, again, with respect to x. So let's go along again, term by term. 2x, well, that's just what we did here, but obviously that was a negative, so this is just going to be 2 here. The minus 2 just disappears. And the minus 12x times minus a half, well, that's minus a half times minus 12. So that's going to become positive. It's going to become plus 6x. And if you take 1 from minus a half, that's going to give me minus 3 over 2. Is that okay? So that's just part A for the 3 marks. Nice and easy. Part B, we've got to verify that C has a stationary point when x is equal to 4. So what this is saying, or what you've got to be able to figure out here, is that when there's a stationary point, this is when dy by dx is equal to 0. So what it's saying is that when x is 4, it implies this here. So x equals 4 implies this. So all you've got to do is just sub this in to your first derivative. So let's sub that in. So we should, when we do it, get that this becomes 0 when we put 4 in. So 2 times 4, well, that's going to give me 8. Minus 2. And then you're going to have to put this in on your calculator. So minus, so I do the x first. So put x in your calculator, so that's going to be 4. Times it, oh, sorry, raise it to the power of minus a half. And then times it by 12. So what you should get for this is 6 here. And then when you actually simplify this, 8 minus 2 is 6. 6 minus 6, 0. Perfect. That's what we wanted to show. That's the key bit there, that we get 0 when we put 4 back into it. So that's the next 2 marks. And then the last part, part C, we've got to determine the nature of this stationary point. So remember, the nature, we've got to look at the second derivative. So we're looking here now, right? This part here. Well, all I'm going to do is put 4 into this now. And when I put 4 into this, I'm going to find out whether it's above 0 or below 0. Remember, if it's above 0, it's a minimum point, and if it's below 0, it's a maximum point. So let's put it in. So I've already done it just to save time, but when you put this in, you should get that the second derivative, y prime prime, prime prime even, comes to 2.75. Well, 2.75 is bigger than 0, so it's a minimum. Min point. And there you go, guys. That's what you're looking to show. So the nature, it just means, is it a max, is it a minimum? And then all you need to put is this, that 2.75 is bigger than 0, and therefore it's a minimum. And there you go, guys.